Welcome to our lesson today on applying trig ratios. So, our goals for today is to use the trig ratios we've been learning for the past few days to solve big complicated word problems. Well, it's not too bad, trust me. Alright, so before we do anything, let's just do a quick review on the three trig ratios. Alright, so we have a triangle right here, right? More importantly, a right triangle. So a triangle with one right angle. This is very important because our trig ratios only work for those triangles with a right angle. Right? So in this case, we are focusing on this angle here, angle P. Right? So just as a formality, this angle right here is denoted as this, right? Angle P. So now, if we are to find the ratio of this angle, right? We see that in this triangle, the long side of the triangle is called the hypotenuse. So this is the diagonal. This is the line, or this is the side of the triangle where it doesn't touch 90 degrees. This line right here is the opposite to this angle P, right? Because it's on the other side of this angle P. And this line right here is adjacent, right? So this line right here is adjacent to the angle P. And now, the three ratios that we use is tangent, sine, and cosine. So, with the tangent of P, we have the opposite divided by or over adjacent, right? So, in this example right here, it will be this side over this side. In this specific triangle, we have the line QR over the line PQ. Right? So again, this line QR over this line PQ. And similarly, the sine of P will be the opposite once again. So this QR line over the hypotenuse, which is PR. Right? So the sine of an angle is opposite over hypotenuse. So in this example, it's QR over PR. And lastly, with cosine, our last remaining angle, or last remaining combination here, adjacent over hypotenuse. So once again, in this case now, we have PQ over PR. Right? So this is what the trigonometric ratio is. All it is a ratio between two lines. Right? Could be opposite of adjacent, opposite of hypotenuse, or adjacent over hypotenuse. Alright, and with all three of those ratios combined, this is where we get the SO, CA, TOA from. Alright, so the S from the sine here is just opposite over hypotenuse, so O over H. The cosine right here is adjacent over hypotenuse, so CAH. And lastly, the TOA is just tangent, which is opposite over adjacent, so TOA. Alright, so this is a neat catchphrase to kind of memorize the trig ratios. With that being said though, let's try some examples. We're trying to solve the triangle XYZ. So all we're doing here is to find every single measurement of this triangle. So every single length and every single angle. And from here, we know that this angle here is 90 degrees as indicated by this square symbol here. We know this side length and this side length given by the question. So all we are left with is we'll define this side length right here. So the side XZ and this angle right here and this angle right here. Right? Because this angle is at the point X that connects the points Y and Z, we write it as angle YXZ. Right? So the middle alphabet here is the angle we're trying to solve. And similarly, we also have the angle XZY. Okay, so Z is the angle in the middle we're trying to solve that connects the point X and the Y. Okay, with that being said, let's start with the line first, because that one was pretty fast. So there are multiple ways you can do this, but the easiest one here in this case is actually using the Pythagoras theorem. So now with the Pythagoras theorem, which I'll write up top, is a squared plus b squared equals to c squared. And in the Pythagoras theorem, the c in this case is the hypotenuse, or the longer side. And we know from here, XZ is the longer side because it is the diagonal of the triangle and it is the line that is opposite to this right angle. And the A and the B are just the side length of those two. Which means that in order to solve XZ, we have again a squared plus b squared equals to c squared. This is pretty much saying 6 squared plus 10 squared equals to xz squared. Right? So this length squared plus this length squared equals to xz squared. Right? We can write it out as 36 plus 100 equals to xz squared. So 136 equals xz squared. And in order to find xy, we just square root both sides. Right? So xz is the square root of 136, which is 11.7. Right? So remember, we have to round our answers to the nearest tenth. Right? So it's 11.6619 blah blah blah. We round it to 11.7. Okay, so that's that. And second, we have the angle yxz. This is 11.7 centimeters. And now let's try to solve the angle yxz here. So this one right there. As we can see, we know all the three side lengths. Right? So we can use any of the SOHCAHTOA we want, right? So let's get I'll write it down here. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So in this case, we can honestly use any we want because we know all three sides. But in this case, we'll just be focusing on the 10 and the 6 because this is the one that's given to us by the answer. If we are to use our hypotenuse, the xz we just found earlier, the answer might be a little bit off because we rounded it to the 10th. So it is always a good habit to use the exact numbers that the question has given us. So now in this case, we see that from this angle, we have an opposite, which is 10 centimeters, and an adjacent, which is 6 centimeters. So we use tangent. Right? We know the opposite side and the adjacent side. Right? So this means that the tangent of yxz is equal to the opposite, which is 10, over hypotenuse, which is 6. Right? And so from here, we can use the inverse tangent function on our calculator. Right? So when we do inverse tangent, right, so just inverse tangent the 10 over 6. So on your calculator, you should press the second function, and most likely the inverse tangent will be above your tangent button. So now another thing to keep in mind here is that we are asking for degrees here. So make sure your calculator is in degrees mode. And now when you type that into a calculator, so the inverse tangent of 10 over 6, all right, we get 59 degrees. All right, so 59.0 something. All right, so it's 59.03 something, but we rounded to nearest tenth, gave us 59 degrees. Okay, so now for our last angle right here, we do the same thing. Right, tangent of the angle xzy is just equal to, so in this case, we have, so now we're looking at this angle right here. We have the opposite, which is now the 6 centimeters, and the adjacent, which is the 10 centimeters. So we have opposite over adjacent. And same thing, we will just inverse tangent this fraction right here to get 31 degrees. Right? So with rounding, the actual answer is 30.96 something, which we round up to 31 degrees. And as we can see here, when we have 59 degrees here and 31 degrees here and then 9 degrees here, they will add up to 180 degrees. Right? So which means that our answers are correct and we have solved the triangle. So we know this angle, we know this angle, we know this side length. We also know this side length, we know this side length, and we know this angle. So that's what solving a triangle is. Okay, so moving on to a word problem now. A road rises 1 meter for every 15 meters measured along the road. So the first step of any word problem is to draw out a diagram, or a triangle, in this case. So let's draw that. So it looks like something like this. So now for every 15 meters measured along the road, so the 15 here will be the hypotenuse. Right, so for every 15 meters you travel, it will go up by 1 meter. So our triangle looks like this. Of course, it's a right angle here. So yeah, 15 meters, travel along the road, we have 1 meter up. And now the question is asking, what is the angle of inclination? So the angle of inclination will be this angle right here. Right, so this is essentially how much the slope actually inclines up. We're trying to solve for this guy right there. So with that being said, let's figure it out. So we know that from this angle's perspective, we only have two numbers we know. This line right here is opposite to it, and this line right here is the hypotenuse, or the longer side. Right? I know this line right here is also adjacent, but we have to remember that this line right here, even though it is adjacent to this angle, it is the longest side of the triangle, it's the hypotenuse. This means that we have to make sure that we're using opposite over hypotenuse instead of opposite over adjacent. So with that being said, our angle or our ratio we are supposed to use is sine. Right? So sine is the one that works with opposite over hypotenuse. So the sine of angle of, let's just do angle A here, will be 1. So opposite over hypotenuse, 15. right? And the next step, of course, we inverse sine. So the angle of inclination is inverse sine of 1 over 15. That gets us 4 degrees right there. Right? So the question is asking us for the nearest degree. So the actual answer is 3.822 something. So we round it up to 4 degrees. Okay? So now, our second part is how far does the car travel horizontally when it travels 15 meters on the road? So the question is now asking for every time the car travels 15 meters, so this is the road here. Every time the car travels 15 meters, how much of the car is actually traveling horizontally? Okay, so because we are going up a diagonal, going up a slope, we are also going horizontally along the road. So we're asking, what is now this distance that we travel? Once again, we can use the Pythagoras theorem, right? Because we know the hypotenuse length, we know one of the side length, we just need the other side length. Which means that, let's just say this line here is h. Right? Oh, that's a big eraser. Let's do h for horizontal. Okay, so once again, Pythagoras is a squared plus b squared equals to c squared. So we have 1 squared plus h squared, so h is the horizontal, equals to 15 squared. Which gets us 1 plus h squared equals to 225. H squared equals to 224. And then we square root both sides, 14.9. Right? Or actually, remember we've got a actual measurement unit here, 14.9 meters. So, which means that as the car travels along the slope, we're going up by 4 degrees, and even though we're driving 15 meters up the slope, we're only traveling 14.9 meters horizontally, right? Because of the 1 meter incline. Alright, so that's pretty much it. This is how we solve a right triangle problem with the ratios and the Pythagoras theorem. So with that being said, let's do some practice questions. So we got 1 word problem and 2 solve the triangle problems. Pause the video here and see how you do. Okay, hope you pause the video and work through it a little bit. Let's figure them out. So, starting with solving each triangle, in this case, we're trying to find the hypotenuse and the short length, as well as this angle right here. Alright, so we're given this angle right here, the 33 degrees from angle U, and we're also given the length that's opposite to this angle, which means that we can use sine, because it's opposite over hypotenuse, to find the hypotenuse, and we can use tangent, which is opposite over adjacent, right? So we can find this adjacent line. So let's do with the hypotenuse first. So we have the sine of 33 degrees is equal to the opposite, which is 12.5, over the hypotenuse, which is TU. Okay, so now we plug in sine 33 in the calculator. We get 0.54 equals to 12.5 over TU. And now we multiply both sides by TU to get that. Let's do brackets here. And then, to isolate for TU, we can just do 12.5 divided by 0.54. Now this gets us 23.1. Right? Or I guess I should have clarified what to round to. Let's just do round to 1 decimal place, or the 10th. Right? So, which means that the hypotenuse is 23.1 centimeters. Okay? We'll move the other triangle out of the way for the time being, just to get more space. Okay, so now let's find the second line here. Okay, so this is the second line we're looking for. We have the tangent of 33 degrees. Okay, so that's opposite over adjacent. So that's opposite, 12.5 again, over adjacent, which is UV. Okay, so the tangent of 33. So from the calculator, the tangent of 33 is 0.65. That equals to 12.5 over UV. We multiply both sides by UV and divide both sides by 0.65 to isolate for the UV. This gets us 19.2 centimeters. Okay, so that's 19.2. And now lastly, with the angle here, we actually didn't really need to use any of the trig ratios because we know that a triangle is 180 degrees. And we have a 90 degrees here and a 33 degrees up there. Which means that the angle will just be 180 degrees minus 33 degrees minus 90 degrees. Right? This gets us 57 degrees. Alright, and that's it. We just solved the triangle there. Alright, so now let's try the other triangle now. in this case now, this is similar to the one we did as the example. So in this case, we don't know this angle, we don't know this angle, and we don't know this length here. Luckily, we can find this length pretty easily using the Pythagorean theorem. So BZ squared, the hypotenuse squared, is the 2 side lengths squared, which means that it is 9.8 squared plus 5.6 squared, which is 127.4, and then we square root both sides to get 11.3 centimeters. Good old Pythagoras, so 1.3 centimeters. Okay, and now we have angle left. So once again, we can use the tangent ratios. So let's go to this angle first. Okay, so with this, So now with this angle, we have the opposite, which is 5.6, and then the adjacent, which is 9.8. So the tangent of the angle AZB is opposite, which is 5.6 over 9.8, which means that angle AZB is just the inverse tangent of that fraction, which is 29.7. And similarly, the tangent of the bottom angle now, so angle ABZ is, in this case, opposite is 9.8, adjacent to 5.6. 9.8 over 5.6. So angle ABZ is just the inverse tangent of 9.8 over 5.6, which is 60.3 degrees. All right, and there we have it. Right, so this angle is 29.7 degrees. This angle down there is 60.3 degrees. Okay, so now for the word problem, just like all word problems, we'll draw a diagram. We're standing 20 meters from the base of the tree, and the angle between us and the top of the tree is 83.4 degrees. Okay, so we have the tree here, something like that. Here's us. So the base here is 20 meters, and this angle is 83.4 degrees. Right? And now the question is asking us how tall is the tree? Right? So how tall is this tree here? So as a more similar triangle, or like a smaller triangle, all we're saying is, here's a right triangle with an angle of 83.4 and 20 meters. We want to solve for this x here. We want to see how tall the tree is. And we're given this angle. We don't know the opposite, but we know the adjacent, which means it's time for sine. So sine of 83.4 degrees is the opposite, which is x, over the adjacent, which is 20. And all we have to do is, to isolate x, is just multiply both sides by 20. Okay, so it's just 20 times sine equals to x. And x will then equal to, x will just equal to 20 meters also, right? Because we are rounding to the nearest degree, or the nearest meter. So yeah, that's pretty much it for our lesson today. Just using trig ratios and knowing how to solve problems with them. Alright, so with that being said, keep practicing and stay hydrated.